So a couple of weeks ago, Igor from MyTechFun approached me, and he's been haunted by the question, how does filaments behave when they are printed at very high speeds? And I think this is the machine to see where the true limits of filaments actually are. So this is pretty much printing one of his test specimens at, let's say, standard settings on a modern Core XY printer. So we're talking 20K accelerations. This is pretty much the slowest I've seen this machine running in quite some time. Later on, we're going to cycle through all the speeds and ultimately go to all the speed. And then Igor is able to translate all of that into meaningful measurements, at least hopefully. If you're new here, let's do a very quick tour on the machine. So starting from the top, we're using 4 filaments. This is from Fiberlogy, the high-speed PLA. These 4 filaments are then being fed into a one-of-a-kind hot end that is specifically designed to output very high flow values. So with this kind of material, we could run all the way up to 400 cubic millimeters per second. As you can see, these 4 extruders are pushing into one solid 1 kilogram copper block down there, which is then again being fed into a single 0.5 millimeter nozzle. The cooling duct you can see down there is another prototype of mine. I printed this one on my Prusa Core 1, which I got very recently, in a PC blend carbon fiber filament, which is holding up pretty good in these temperatures. And if we have like a broader look on the kinematics here, this is all based on a winch kinematic. So all of these 4 motors are connected via a rope to the central platform. All of that is on a very solid granite plate. This whole machine is based off an old CMM. Weighs 1300 kilograms, and if you have a look down here, there is an air inlet which builds pressure below the printing surface or build plate, you might say, and therefore you get a double-sided air cushion. It's an air bearing essentially. Igor and I did talk quite some about how to make all these tests here scientifically reliable, and it's not too easy because there are so many factors involved. We came up with the idea of having layer times to be the main variable here. And in the standard settings of a Bambu Lab printer, this is set around 8 seconds per layer on a PLA. I'm going to do 8 as well to make it comparable, to have at least a same reference. And then we're going down to like 4, 2, 1, half a second or something. And try to find out what this actually translates to in terms of the strength of the part. And yeah, right here at the end it's gonna speed up some because it's gonna do solid layers and it has to maintain that 8-second layer time. And yeah, next one we're gonna do is gonna be 4 seconds of layer time. So you see it's pretty much double the speed. And this time I'm going to do the slightest amount of cooling that is possible. So just for a little sanity check, all these 3 specimens are estimated at about 8.25 grams of filament. So we're pretty much spot on, don't have any under extrusion or stuff like that. So next one is going to be 2 seconds of layer time, and this is the first where I have to increase accelerations a bit. I'm going from 20K, which is pretty standard as a maximum for Core XY printers nowadays. I'm going up to 50K to reach those speeds there. For the next one, which is going to be 1 second layer time, we're gonna have to throw some juice in it. This is 250k accelerations. This results in speeds somewhere in the range of 300 to 700 millimeters a second, with the top infill being at 1500, which is right now a reference speed. Let's run that. First layer is always slow for good adhesion. For doing 0.5 seconds layer time, this is what our speed tab actually looks like. Everything in red is 1500. Here in the middle, where like the specimen counts, this is somewhere like 750 or something. And we're gonna go up with the accelerations to 500k. And yeah, for the last test with this specimen, we're going without any layer time limitation. 750k of accelerations and flat 1500 millimeters a second. So this acceleration is 75 times Earth gravitational field. This machine has run 200 G. I won't do that right now because this has all been calibrated at a different temperature. Last time I was on a machine was like 2 months ago. I got 13 degrees here in the company right now. And I don't want to mess things up because I got plans for it starting tomorrow. The last was being extruded at, let's say, 140 cubic millimeters a second. Still no signs of under-extrusion here. So this is my lineup of this exact specimen. Now we're going to do all the other tests, and we're going to go with kind of these settings. Half a second of layer time. I think we were at 500k accelerations, and whatever, like maximum speed is 1500 millimeters a second. But this is again being brought down a bit by the layer time minima. So next up we're gonna do these S-hooks and the creep test. And yeah, then both of these specimens, once that is testing like XY strength and then Z layer adhesion strength. So let's take a real quick break here and talk about our today's video sponsor, which is PCBWay. So PCBWay has been a long-time sponsor of this channel and also this machine. A lot of those parts you can see here are actually made by them. So for example, all these motor mounts are SLM printed in solid aluminum, as well as these pulleys here, which are a polyjetted nylon. And then again, all sorts of other stuff. So basically my complete open source hot end, which is also SLM printed, is made by PCBWay. So down there in the video description, there is a link where you get a small discount on your first order there. It is really easy. You just hop on the PCBWay website, upload your files in what you got on hand, select your desired materials and quantity, and basically you get an instant quote. If there's anything wrong with your files, etc., an engineer will contact you and help you out to get things sorted. So again, PCBWay, thank you so much for sponsoring that content. Without your help, I couldn't have investigated all this stupid stuff I do here on a daily basis. Thank you. This is pretty much the parts I'm going to be sending Igor, and these are right off the machine. And in terms of settings, I didn't touch the printing speed. It's still at 1500 millimeters a second, but I dialed down accelerations to 250K. As you can see, all of these do feature a bit of stringing, especially those pillar-like things. My Minuteman profile I got here is mostly tuned for benchy purposes. I'm not running any retractions, but in these multi-part arrangement it does show. Otherwise, I'm really happy with these parts. It depends on the specific arrangement, but these are somewhere between 10 and 20 times faster than a modern Core XY can do if you max it out. And you guys probably know, if you run everything into like crazy mode and overrun everything by 200%, these parts don't come out perfect either. Prediction time. The amount of people that post under my videos that these are not strong is high, and I don't think this is true. These parts clearly do have a certain strength to it. How comparable that is to usual 3D printing? That is what we're trying to find out. So I think the fundamental thing that is happening here, you're gonna extrude a layer which needs a certain time to cool to the glass transition temperature. If it does not, the material on the next layer won't have like a solid ground to stick to. And then of course cooling etc. will just blow it somewhere. If it has cooled properly, the next layer that is applied on top of that needs to have a certain energy, and that energy needs to be high enough to remelt the previous layer to get a proper bonding between them. So therefore, my conclusion would be that as long as you can keep the previous layer cooled down enough, and you're gonna have the next layer of high enough energy to remelt the previous one, then you're gonna end up with somewhat of the same strength in your part. But the exception to the rules comes if you either cool down your newly extruded material so fast that the time isn't enough to actually remelt the previous one. This is case A. Or case B, there are a few videos up here on my channel where I did all the stupid stuff in terms of cooling methods. So I used liquid nitrogen and dry ice and whatnot. And all of these were cooling the previous filament to sub-0 degrees ambient temperature. And therefore, again, the energy needed in order to remelt the previous layer is becoming more and more and more. And right there, I also noticed parts getting weaker and weaker if I don't like counteract with a certain temperature coming from the newly extruded material. And so I think as long as we stay in that gap that is becoming increasingly narrow, the faster we go, we can have strong parts. And it's up to the guys that build really proper filament profiles to detect this kind of stuff, to gather all the information about cooling media and temperatures and whatnot, and then calculate all of this. So I think if we don't just want to go faster but keep our strength level, this is what becomes the necessity to integrate in our slicing profiles. But this is just my 2 cents. We'll have to judge if this is a true statement after Igor has destroyed all of these specimens here. So maybe these will help us to get a better understanding of the fundamental principles that are involved. So I hope you enjoyed this little side quest here. My name is Jan, and I build stuff so you don't have to. See you in the next one. Bye.